Hey, hello guys, welcome back. For context, we are trying to write an operating system from scratch, currently working on a UEFI bootloader. Let's get to it. Right, so last time we did this. I think we have created this address space here. We have tested it a bit to see that it does what we needed it to do. And we've stopped there. So today, I guess let's start by actually mapping the things we need to map. And to make that easy, let me just bring up so main.c. I think we have this map kernel space here, which is what we are going to basically do. Let me just do this, bring it up here. And let's see what we have. Right, so I guess we could start by removing all of this this code, and we can just go ahead and do just call map kernel space, which would take so address space as a pointer. What else would we need? I guess we need kernel info. So I guess we have that under kernel info there. Is that a pointer? No, it's not. So let's take a ref to that, and we'll see where we go from there. Right. So let's create a function map kernel space, which would take so address space, which is a pointer to an address space, and it takes kernel info, which is a pointer to const kernel info, which we don't have, but I think so where is our kernel info? So kernel info should be declared under this. It's public, so we can access it that way. Right, so this would be kernel loader dot kernel info, and I think we are going to need to allocate pages. So bootloader error, otherwise void, I think. That looks okay. Right, so from memory, before I look at the C code, I think we have a few things to do. So first of all, we need to map the core stacks for every core we have. Then we need to map the kernel. Then we need to map the boot info struct and the environment, but also I guess the frame buffer, so that we can draw to it, and then TBD, I guess. Right, so we don't have bootloader error. Let's get started on that. Const bootloader error is import errors, I guess. That's zig. Bootloader error. There we go. Right, so we are going to need to allocate pages. So I'm tempted to do something like, if I remember correctly, we have under address space, we have done something to make that easy. Yeah, so we have this helper here, which basically does just that. So if I just remove this from here, I could go ahead and create mem helper maybe .zig, and under this I could just make this public and import so const bootloader error, which is import from errors errors.sig. So bootloader error. What else do we need? Constants. So constants is import constants.sig, and globals. Globals is import globals.sig. There we go. Anything else we need? Stud, I guess. Const stud is import stud. And we might want to create a logger. So stud log scoped to mem helper. There we go. Probably remove. Maybe just this part here. And probably do something like this, I guess. So number of pages, and we want the so int from pointer of page pointer. Yep. Yep, that looks pretty good. So let's fix what we've broken. So here we are going to need const mem helper is import mem helper.seg, and if I go to our diagnostics here, we can do mem helper dot, and that should be okay. Do we have? Yep, we do have another one. Oops. So mem helper. Okay, and that's pretty much it for this one. I guess we could use this helper here for other parts of our bootloader here. But for now, I'll just leave them be. Right, so let's take a look at what we did here. So we started the core stacks from 0. So basically the first stack would be starting from minus page size to 0, and then the second core would have its stack start from minus 2 page sizes to page size to minus page size, etc. So let's redo the same thing, I guess. So for I AU64 starts at 0. So while I is less than I guess max cores, we need to constants dot max CPU. Yeah, max CPU looks okay. And here we do I plus equal constants dot arc page size. That looks pretty good. Right. So I guess we should do this. So core stack pointer is try to mem helper dot allocate pages just 1, and I guess we are going to need const mem helper is import mem helper dot sig, and so that's okay. And then we do address space dot mmap, and to this we need to pass so the address, which is a bitcast of that pointer to so we need to pointer cast, so int from pointer of core stack pointer. I'm guessing that this is what we need to do, and then the actual address, so the actual physical address we need to map to p_adder is, I guess, just I. Yeah, looks okay, I think. Actually, this should be a minus, and this should probably be minus constants arc page size. Yep. And that should be fine. And here for the flags. So I think for the flags, I'm going to do something to just create a set of default flags. So I'll go here, const default mmap flags. And that would be, of course, a mmap flags thingy. And this would be, so just present and read write, which is read write. And just add this here, make my life easier. All right. So that's pretty much all I need to do. So here, address space is the namespace. And of course, we forgot to make the default flags public. So pub there, and that should make this easier. So default, mmap flags. All right. Here I'm just gonna put this to make it a bit better, and that looks okay, I think. Yeah, that looks pretty good. So let's probably just add a logger here. So const log is std log scoped to I guess kernel space mapper, and here we can do log.debug, and inside here we can say, I guess we could copy the same message. Mapping core stacks to there we go, something like this, and we can put I guess we need this up here, and I guess we could put I in there. Yeah, looks pretty good. That looks pretty good. And obviously here we need to go to constants, make a pub const max CPU, which would be, I have no idea what the max CPU was on here. 64, right? 64 looks sounds good. Let's now move to kernel. So kernel, we have under kernel info, I think we have this segment mappings, which are basically just segments on their start and end, and they are already in memory, so we don't really need to allocate them. So let's just do a for loop over kernel info dot segment mappings, and we'll capture that as mapping. And we are going to do address space dot mmap. I think we already have, so the address is, so we should have mapping dot the address, right? But that's an address. Huh. Yeah, so I guess, yeah, so I guess we could just do mapping dot the address, mapping dot the address, and address space, default MF flags. There you go. That was easier than expected. Right, so maybe we could also print something. So let me just go ahead and yank this from here. Put this. So what do we write here? So mapping kernel segment. And here I'll do 0x hex, arrow, and 0x hex for physical and virtual addresses. So here we do so as U64 bitcast mapping dot v address, and the other one would just be mapping dot, or rather we also need to cast it as a U64. Yeah, so U64 bitcast mapping dot p address, and probably add this here, and there we go. Right, so that's that. Let's get on with the bootloader or boot info. I guess boot info we don't really have anywhere here. Actually, we should have it. So what did we do with the boot info symbols? So we just printed them. Cool. Cool. So kernel info dot boot info address is symbol dot st value. Right. So let's pick that from there and do what's this frame buffer? So FB address, that should be the same, and let's pick that from here, and this would be env address. Right. And if we go back to kernel info, there you go. So here we are going to add boot info address, and this would be an optional U64 with a default value of null. And actually, let me just copy these. That would be env address. Right, so if we go back now to our main, we should do if kernel info boot info address as boot info address. And if that's the correct thing, we do address space. And if that's the correct thing, we do address space dot map. So the virtual address for that would be bitcast. I guess boot info address is the virtual address we want. The physical address, though, p address, we don't really have boot info pointer. Yeah. And of course, this needs a few flags. So address space. So default mm flags. Right. So we need the physical address of that boot info struct. Actually, we need the physical address of all the structs we have. except the frame buffer. No, we actually need the frame buffer's address also. Right. So I guess we could do boot info pointer as a U64, frame buffer pointer as a U64, just so that we don't have to do any conversions here in this function. We'll leave that for later. Right, and I guess we could pretty much just copy the same thing, change boot info for frame buffer, and we should be good to go for that. And we could do the same thing here, change frame buffer for env, and we should be good to go. Right, so what else do we need? Oh, right, we need to identity map some of the memory so that we can access our structs from the kernel. Right, so how do we do that? I guess that should be fairly simple. So identity mapping. Right, so let's redeclare an I, or maybe we can just reuse the I we've declared before. Set that to 0 and do while I is less than. I think we already have this megabyte something in Zig. Yeah. So we already have these here. Okay. Well, we don't have them there anymore. They're coming over here. And let me just do this. Right. Let's fix what we've broken, I guess. So this one would be mem helper. Oops. Dot and we make that. So of course here we need to add mem helper, which is import mem helper.zig. Right, so I guess that's our problem fixed. And here we can go ahead and do mem helper.mb. Right, so we haven't made those public. Right. Okay, so and we want 64 megabytes. And we also want this to have plus equal constants arc page size. And we are going to go ahead and do so address space a map, and the v address here would be so bitcast of I, and the physical address would just be I guess we bitcast cast I also, and of course here we shouldn't forget the address space default flags. Right, and that should be pretty much it. So this one here, boot info struct, we know that it's a single page env should be the same, but I think get frame buffer size. Actually, let's do that right now. Right, so we need the frame buffer address, but we also need the frame buffer size for us to be able to map all the pages that might make up the frame buffer. So where do we have frame buffer? Get frame buffer. That looks promising. Let's go into that. And here we have horizontal resolution, vertical resolution, and we have pixels per scan line. But we are more, okay, so here in boot info, we have scan line bytes, and we have the height in scan lines. So if we multiply these two here, we should have the actual total size of the frame buffer. Yeah. And I guess we could do that. So let's go back here. And in here, I'm just going to take frame buffer pointer, and I'm going to take frame buffer size as a U64. There we go. Right, so frame buffer size. We have the address, so we should go into that, and then we should probably just do the exact same thing we did here. But yeah, so let's take I, initialize that to FP address, right? And while I is less than FP address plus FP size, so here I'm just going to mark a to do, which is make sure the size is page lined. Just so that we know that this and address here would be at the end of a page. Otherwise, we will be mapping more than we should, and that would be a problem. Right, so while that is that, and we want to actually go ahead and do I plus equal constants dot arc page size, and we want to bring that up there. And I guess that's pretty much all we need to do. We just want, oh wait, hold on. So we want frame buffer address. Okay, so I is the actual, right, so we will probably just create two variables here. So this one would be FB v address, and this one here would be FB p address. And this would be a U64, of course, and this here would be frame buffer pointer. So I guess I don't need to do this. And here I'm going to do, so either of them, so let's take the p address, I guess, is less than frame buffer pointer, plus frame buffer size. And this would be frame buffer with p address plus equal that. And actually we'll, we will need to do something like this to create a block, and I'll do this, and then I'll do frame buffer v address also is plus equal constants.arcpage size. There we go. That should do it. Let me just get rid of the other window and take a look at this. Right, so that should do it. So if I go here to where we had I should just substitute that with the address, and p address would just be frame buffer p address. If everything is correct, actually let me just go ahead and add commas to pretty much all of these, just so that we have something nice. And also let me go ahead and add a comma here. So I think that looks pretty okay. So we'll need to probably go over this, make sure that it's all right. Actually, let me just go ahead and do something here. Log.debug. I'm just gonna print so mapping frame buffer from, so I'll just do something like this to 0x hex, and here I'll put size. Yeah, I'll put size in hex, I guess. So here we want frame buffer pointer, yep, and then frame buffer address and FB size. There we go. So let's go back to map kernel space. There we go. Let's go back here. This needs a boot info pointer. So that would be boot info. What's that? That's a pointer, I think. Yep. But we needed that as an int, so int from pointer, boot info. And we need int from pointer, which is the frame buffer pointer. So it would be boot info dot frame buffer pointer, which is already a U64. Okay, so and it's a nullable U64. So boot info dot frame buffer pointer, and then we need boot info dot frame buffer height times, and I guess all of these are optionals, right? Okay, so we might want to extract this somewhere here. So const frame buffer pointer is boot info dot fb pointer, or else 0, I guess. Yeah, sure, why not? And const FB size is boot info FB height, or else 0. Can we do something like this? Times boot info dot FB scanline bytes, or else 0. What's this? That's a U32. This one is a nullable U32, and I should probably do as U64 over here, and add a second one of those, and here as U64, and there we go. That should be All right. So let's change those. So this would be FB pointer, and this would be FB size. And of course, we need some other things, which are the environment pointer. How do we get that? How did we get the config? So we have this config object here. And if I go into load file, what is it returning? So it returns this. Buffer is content, and content is page aligned. So this is what we want actually. Right. So here we'll do config buffer, and we'll convert that to int. There we go. Come on. Okay. So I guess that's pretty much all we need. So let's build this and see where we messed up. Okay, so MB is not marked as Bob. I thought it was. Huh, okay. Address space, but found const address space. Okay, that's an easy fix. So where did we declare it? There we go. So that needs to be a variable. And let's see. Expected pointer found a slice of U8. Right. That needs to be dot pointer, I think. And what now? Error union is ignored, of course, because we need to add the classic catch block. Let me just do this. Should not map kernel address space. Should not map kernel address space. Yep. Okay. What else? U64 cannot, of course it can. So let's do this, go over here, and this is an i64 now. And this, actually no, this would still have to be a U64, but here we are just going to bitcast it, I guess. I'm not sure if intcast would help us here. Keeping the same numerical value, the type is inferred. Okay, so let's see. Let's see if this helps. Okay. So let's bitcast that and hope for the best. Cannot bitcast from comp time end. Okay, so as i64 and we do this. How's that? Error union is ignored. Mmap, of course, every time we call mmap, we should just put a try in front of that. Could have made a macro, but so try and try, and of course this one too. Okay. Bitcast cannot bitcast from address. Union does not have a guaranteed in-memory layout. Huh. Okay. Oh, I guess we are going to need to where was that? I guess this. Right, so address does not have a fixed memory layout, so we are not going to be able to do what we try to do. All right. Well, here's what we're gonna do then. Just gonna go over here, and probably just do. Well, I guess it might have been an error to create a single address type for both virtual and physical addresses, but I guess we're far past that now. Right, so let's get this going. So mapping v address is switch on mapping v address, and I guess in both cases, so p address or v address, we should just do this and return bitcast or as U64 bitcast of x. Okay, and pretty much the same goes for p address. And here we can just go ahead and do so mapping p address and mapping v address. Okay, let's see if that's any better. Capture group with incompatible types. Right, so that's what I was afraid of. Right, so let's remove this from here and let's do v address. And here we'll do pretty much the same. So as U64 bitcast, and this time it should go through because we know that these are the two cases we have. There we go. Okay, so it looks like it's building. So let's go ahead and run that. Could not map kernel address space. What is this? Kernel segment. Hold on a minute. Mapping kernels. Oops. Mapping kernel segment. That's this one here. Yeah, actually, let me just do something here. Unreachable. Oops. And this one here is a p address, so I guess we could map this or mark this as unreachable. Okay. Huh. All right. So the physical address we have is bad. All right. Well, that's kind of scary. So let's just do something here. Let's just log debug and do something like kernel segment and just map the entire struct mapping. Okay. Let's see what we get. So kernel mapping p address is we have a virtual address in the physical address. Okay. Kernel loader p address. P address is int from pointer load buffer. Okay, that looks good, I guess. So where the hell? Okay, so let's see where we're setting this p address. So this is the only place we are actually setting this p address. So let's add a debug log here. Added entry any, and to this we are going to print I guess that. Yeah. Okay. Let's see where let's see where it all went wrong. So added entry. So this one is a p address with its corresponding v address. Do we have any more entries? No. So how does it get messed up then? Wait, hold on. Okay, is this a classic case of this just being a... Well, I guess no. That looks okay. Okay, you know what? I'll keep this in here, but I'll go to main, right where we get the kernel info, and I should do something like stdlog debug kernel info, and here we just dump the whole thing, I guess. Let's see here. So kernel info. Okay. Okay. I think I know what's happening here. I think I know. It's the classic case of this being a local variable that gets Yep. This is a local variable. We are returning a pointer to a local variable here, which is not good to say the least. Right. So let's do something like, yeah, undefined. Oops. And actually, let me do that. Kernel info is, or rather, something like this. Should be that. Let me join this line. And here I'm just gonna go ahead and allocate this. So do we have status? Yes, we do. Is globals, boot services, as we know, and we should do allocate pool. Yeah, memory type is loader. Data size is at size of come on kernel info, and the buffer is pointer cast of, so we need a pointer to a pointer of kernel info. And obviously we need to do the check, the status check. So switch on status, and we are expecting success. Obviously this is a an enum, in which case we should do log dot debug allocated kernel info struct. Probably put the address somewhere. And the address would come from int from pointer of kernel info. Or actually, we could just do something even better. Kernel info, and we could just go here and do something like this. Right. And otherwise, we should return a bootloader error. Do we have something that allocation failed, or kernel info? Maybe do something like this. Allocate kernel info. There we go. So this one needs to be that. And this one doesn't exist. Actually, that one exists. Right, so let's go ahead and just copy this, go all the way down here, probably put that in, and go back. Okay. So if this goes correctly, we should now return a pointer to kernel info, which we shall do. And we should probably go back to main sig and get that as a pointer. So why? Right. Okay, so this one here needs to also return the same pointer. And if we go back, so what's the problem here? Main.sig. Okay, so now it's recognizing this as a pointer, and now we can just go ahead and print its content, and we should be good to go, I guess. So this one needs to be just a normal value. All right, I think we'll have a few problems. No? Okay, so no problems. let's see what we get. Okay, so we have another problem here. Right. Where is kernel info? Added entry. Okay. Right. And here, what do we have? So this is, again, I feel like this is wrong, maybe. I'm gonna need to convert this to hex to C. Try to convert that to hex. It looks okay. So we do have the correct address there, or entry point. Okay, so let's do this again. So kernel info create. The entry point is correct. Segment mappings, I guess I'm gonna need to drill down on those, but the length of some of these things are pretty big. Yeah, and I'm not sure why. Okay, so here we add a first entry. So we have a physical address of that. We have a length of 18. Is that length of pages? I forgot. Right, so here when we print the mapping info, so we do have some weirdness. Yeah, kernel info. So this one is still okay. We have our length of 18. These other ones are, I think the other ones are the undefined. Okay, so we might need to address that. Frame buffer looks pretty much the same as the entry point, so that looks okay. VM address is null, and boot info looks pretty okay. Right. So, and I guess AF is also and indicates that we have a undefined issue here. Right, so let's fix that. So this one here would need to be nullable, I guess, and they all would need to be a an array of mapping info. With just nulls inside. Something like this. Let's see how that does. Okay, doesn't like that. Optional type does not support field access, of course. Okay, so that's not really what we wanted to do then. Okay, so let's put these back to undefined. And let's just do the easy thing for now and add a segment count, which should be a U3. Yeah, let's make that a U64 just to align. Now let's make that a U8 just to align all of them. And that would be a 0. And we go down here. We create the mapping at mapping index. So what's mapping index then? So it starts at 0 and then it gets incremented. Okay, so I guess we could come down here, kernel info, dot segment count, and we just intcast that to, what was that? Mapping index, I guess. Right, that looks okay. So that's mem size. Mem size is in what? In um okay. So let's first check that this actually builds, and we'll see. Okay. Right. So what do we have here? Kernel info, yeah. So I'm looking for segment count. Okay, so we do have 2 segments. That's great. Okay, cool. So we can use segment count now for, so we want to go to main, and we want to go all the way down here somewhere. Right, so here. And we want to do something like this. So this would become 0 to, yeah, I think we can do that, or can't we? So that would become kernel info dot segment count. And that would become an I. And we'll have const mapping is a pointer to kernel info dot segment mappings at index I. How's that? Capture shadows, okay. So call that index and call that index. Right. Let's see now. So we do still have the same problem. And I'm thinking that, okay, so we might only have a single mapping, and we are getting bamboozled by this since it gets incremented before we do the check. So let's take mapping index -1 then. Okay, let's see now. Okay, so we are doing some mappings. Okay. I think our frame buffer is actually causing this, since it's should be fairly large, I think. So let's let's just comment out the frame buffer. Oops. Let's comment all of these things out. And what is the problem? Unused. Okay. So FB pointer, I think, and FB size. All right. Okay, let's see now. We're still mapping too many things. Okay. We are still mapping too many things. So I'll just go ahead and do this also. All right. Okay. That looks more like it. The only problem that I have with this is the kernel length says that it's 18, which we haven't taken into account actually. So we will need to do that. So I guess there's just one more thing to do here, which is while mapping the segments, we are never using the size of the segment, which is bad. So we should probably do that. So const num pages would be so 1 plus, or actually we could use seal of basically the mapping length divided by constants arc page size. Right, so with that we should have a variable, I guess let's call it p, which is 0. Oh, actually, we don't really need to do that. We should just do for 0 to num pages, capture that as p, which is the number of the page we are trying to map, and just take all of these up here, and we do something like this, and here we should recompute. So we should recompute the virtual address and physical address, right? So I guess this and this can become a variable, and here we should do so mapping p address is p times constants arc page size, and same goes for the virtual address, I think. And here we should just replace that with v address, and this one here is mapping p address, I think. Right, and just to make sure of that, I'm just gonna, maybe I should take the whole thing, just bring that here, and what am I going to do here? I think just do something like this. Part or let me just do something like this, and this one here would be P. Yeah, that looks pretty okay. Let's rebuild this. Okay, what's that? Expected vector of floats or float type found U16. Okay, so let's not do that. So I guess we could do something like this. Expected address found U16. Okay. That's fair. So let's so the address, and this would be, we're just gonna bitcast mapping the address to that. And this one here should be pretty much the same, I think. P address, and that would just be mapping the address. Okay. Okay, let's see then. Kernel segment. So mapping kernel segment from that to that, and we have one segment that got mapped. Cool. That looks pretty good. Yep. So I guess we've allocated the pages that we needed for the page levels, and after the mapping we have the entry here, which has this value here with the correct flags. The entry itself was this physical address here, so that translates correctly. Here we are trying to allocate something else for E. I think that's I'm probably going to add a debug log here. So log debug and mapping boot info struct and I'll do something like this, something like that. And here, what do we have? We have a boot info pointer, right? That goes to boot info adder, and it's a single page, so that's fine. We should probably, okay, so we already have one for the frame buffer, and we should do the same for so env struct or just env, and this would be, actually let's just substitute boot info for env. There we go. And actually there's yet another problem I've seen, but we'll get to that in a jiffy. Okay, so what do we have here? Core stacks. I'm not seeing any allocations for the core stacks, which is making me very worried, but probably gonna need to add a few more logs there. Okay, so segment is that we are mapping one single segment, then we are mapping the boot info struct there, which translates correctly. And let me just move this out. And then we are trying to well, that's pretty much it, I guess. And yeah, okay, so here we are just printing the address space. So if we have no address requested by the kernel in its symbols, then we just don't map it, which is weird, but I guess that's okay. Yeah, I'm not gonna make changes to that. I think that's pretty okay. Let's just bring back the frame buffer now and see that all goes well. Actually, let me just get rid of a few things. Right. Oops. So I'm actually gonna do something like this first. Here, core stack, or rather core D stack from, or rather, let's do something like this, physical, and then just arrow into the virtual address. So I is the stack, the core ID, or rather, okay. So we actually messed up here. Yeah, we actually did mess up. Okay. Right. So actually, let me just get rid of that. Do a classic for loop for 0 to constant max CPU. Capture that as I, right? And go up here and just do core stack address v address. There we go. And with that, I could get rid of this. And I could go down here and do core stack v address minus equal constants arc page size. So that's okay. And we have a pointer, and we are going to map the pointer to core stack v address. Wait, hold on, no. Okay, so that was core stack pointer is the physical address. Okay, so this was wrong to begin with. Okay, good thing we've caught that. Right, so p address is so this one would just need to be int from pointer core stack pointer, and this one though would need to be a bitcast of that core stack v address that we've computed before. Right. Yeah. Okay. That looks much better. So that would be I, which is the actual core, and then we'll have the physical address, which is core, or rather, it's a int from pointer, which is core stack pointer, and then we'll have the v address, which is core stack v address. Right. Okay. That looks much better, I think. Let's see what we have. Okay, so we are mapping a few more things. Let's go all the way up to, actually, let me just find So kernel mapping. What was it? Kernel. There we go. So kernel segment gets mapped here. Then we have the boot info. We have the frame buffer that gets mapped. So from this address here, which is the physical address, to where our kernel expects it. And then we are mapping a few pages for the frame buffer. And I guess we wanted to also check the core mappings. Okay, so let's take a look. So mapping core 0 stack goes from -1 page to 0, and then this one goes from -2 pages to 0, and so on and so forth. Okay, that looks pretty good, I think. And of course we have 64 cores, so it goes to core ID 63. Cool. So that looks like it's working, I think. And here we are printing the memory map, or rather the virtual address mappings. But overall, I think it looks okay. Well, that's all I have time for today. If at any point you've liked this video, please leave a like and subscribe. And maybe consider sharing it with someone who this type of content may interest. This was writing a UEFI bootloader from scratch. Fucking out.